You're welcome back. Today we want to discuss differential calculus. Here you will have differential calculus. We have a calculus which is divided into two. We have differential calculus and then we have integral calculus. But this aspect we want to discuss is integral calculus. Then it has different. There are different parts of in different differential calculus or subtopic under it, starting from limit towards first principle. Then we have sum, you have a chain rule, you have quotient rule, then product rule and the like. So let's start. Now the first part here we are talking about differential calculus. Now the first part, as I told you, is limit. What do you understand by limit? Limit is simply mean you limit a value into certain number, maybe as a number approach. A number can be talking about number approaching 1, 2, 3. Maybe if it like this number now, you can say it's approach 1 when it's approach. So you can have this approaching 2, 3, 4, 5. So you simply limit it that maybe the number is a particular one. So that is what we have. Now limit. There are different questions that we have in limit which demand different method. You can use different method or approach to solve it. So we have direct method. Direct method has to do with when you are given a limit, that is, a value is limited to certain thing, you can substitute it directly. So that's it. Why sum? If you substitute it directly, it can give you an indeterminate value, which we call infinity. It can be product, it can be division, it can be multiplication, or whatever. So, like, let's talk about direct, like direct substitution. Direct substitution. Now, take for instance, you have an expression which is, let's say, the functions of x, which is x raised to power 3 minus 5x squared plus 3 plus 3x minus plus 10, let's say plus 2. Then the limit is when the x tend to what? Let's say the x tend to 1. So you want to know the value of this expression as x tend to 1. So for this one, you can simply do direct substitution. So what you have here is x raised to power 3 limit. The limit is here you have, you can be 10 to 1 minus 5. So here you have the limit here. The limit of x tend to what? 1. So plus 3. The limit x here tend to 1. Here is x plus 2. And so on. So you don't need what do you call it? You may not put limits. You can simply substitute it directly, still the same thing, but normal you can express it like this. So here, what you simply do is that for this, where you see x, you put the 1 there. So 1 raised to power 3 minus what? 5 times 1 squared plus 3 times 1 plus 2. So that's what we have. Here is 1 minus 5. 5 square, 1 square is 1. Times 5 will give you 5. 3 times this, you have 3 plus 2. So this minus this will give you minus 4. Minus 4 plus 3 will give you we give you minus 1. Minus 1 plus what do you call it? We give you 1. So the value of this expression will be this. That's 1. As s tends to 0. So let's look at another one. Now, let's say you have an expression like this, s squared plus 5x, s squared minus 5x plus 6, then divided by x minus 1. Let's say we have s plus 2. Like this one now, if you want to, let's say the limit x tend to 1. For this expression, if s tend to 1, you want to look at them. You want to test. You can look. You just look at it. If you substitute 1 into this, will it give you solid real value? So for this one now, the limit, the rest of some, you simply have 1 square minus 5 times 1 plus 6 over 1 plus what? 2. So for this one, you have this is 1 minus 5 plus 6 over 3. So 1 plus this, you have 6, 7. Minus this, you have 2 over 3. So the value of this expression as s tends to 1 is 2 over 3. So that's the answer. Again, let's still have this. Then let's say that we have s minus 2. Here, let's just change this one to minus 2. Then let's say that here, this value now, s tends to 2. Look at it. Let's look at this one, this expression. As s tends to 2, if this s is tending to 2, here we are still dealing with the same question. When s is 10 to 2, then if you want to substitute directly, so you will discover that what you have, 2 squared is 4. 2 times 5 is what? 10 plus 6 over 2 minus 2 is 0. So what you have here, this plus this is what? 10 minus that's 0 over 0. So it will give you undefined. That's indeterminate. So with this, as you substitute it, that's so that it cannot go work. So there is other way you can try it. One of the way is by factoring method. So once you come across something like this, then you can use factoring method to solve it. It has solution. Then you can use other means once you get into this. Now, there are different expressions you can get that can be indeterminate. Like you have here, like 0 over 0 is indeterminate. Like this one, like this one divided and multiplied by the same thing, or infinity divided by infinity. So you will have them like that, or 1 raised by infinity. So and you have different forms like that, or infinity minus infinity, or infinity plus infinity, or anything that can give you uncertain, that is on indeterminate value. So you will use other method to solve it. So one of the methods you are going to use to solve it is factoring method. So what is factoring method? Is you factorize. So you factorize. So that's, here we have direct. Another one, once the direct solution lead to indeterminate value, then you use factoring method. So here you have, now you can factorize this. How are you going to factorize this? This is 6. So the factor of 6 is what? 1 and 6 and what? 2 and 3. 1 and this. So you need 2 numbers. If you add them together, you get minus 5. If you divide them, if you multiply them, you are going to get plus 6. So what are the 2 numbers from this factor? So you put minus and minus 8. Minus 2 plus minus 3 will give you minus 5. Minus 2 times minus 3 will give you plus 6. So You come and substitute into this place. So what do you have? You will have the limit x tend to 2. Here is give you x squared minus 3x minus 2x plus 6 over x minus 2. So what you have here, this x minus 2. What you have here, so you bracket this one 2 by 2 minus 2x. Look at this minus. When you put this into brackets, it will change this one. Minus times plus, this one will give you minus 6 into brackets. So you have x minus 2. So your s tends towards 2. That's the limit. So what is common here is what? Here. What is common here is x. So you will have 1x here minus 3. So what is common here is 2, x minus 3. So you have s minus 2. Then you have the limit x tend towards 2. Then what about it? What is common to both sides? You have x minus 3, x plus 2. So you combine this together, divided by x plus 2. So here, this cancel this. Then you will have s minus 3. Then the limit now, s2. So you place x here, s minus 3, you also s minus 1. So that is it. So you have it like that. Then let's say you have that's another method you can use once you have a determinate value. So let's take another example. Look at this one. By the same factoring method, let's have x raised to power 3 minus 8 x minus 2. As x tends to 2, the limit, there you have limit x tends to 2, s approach 2. So here, now if you want to substitute directly, as I told you that time, 2 raised to power 3 is going to give you 8. And 8 minus 8, 2 minus 2, you will have 2 over 2. That is 0 over 0. That's indeterminate. Then what are you going to do? You use factoring method. So by factoring method, this divided by this, how are you going to get to that? This is what you are going to do. You will have, so you use this one to divide it. How are you going to divide it? There's what this polynomial. So division of polynomial, you can use trial by error method. Trial by error methods mean this divisor, if we equate it to 0, then x here equal to 2. If you substitute this one into this, and then it will give you 0. When it gives you 0, it means this can divide this. Since you have confirmed, if you substitute the 8 minus 8 is 0. So this is a factor, this is one of the factors of this. So you come and do your long division like this. Here you have 8 raised to x raised to power 3 minus 8. You put the divisor here. Now 3 raised to power x divided by x, you have x squared. X times x, you have x raised to power 3. Minus 3 times this is going to give you minus x raised to power 2. Now look, what are you going to do now? This minus this 0. 0 minus. Now, this one has no common factor here. So the factor that will be there, it seems like is 0 x raised to power 3, which is still 0. You multiply 0 with 0. So it's like that. So you have this one is 0, this minus this. So this one is going to give you 3 raised to power 2 squared. This is what I'm saying. Is 0 raised to power 3 minus. That is what we are doing. You are doing it. You are minusing this. This one has minus. This minus this. So minus times minus is plus. Then plus 3x squared. So if you add this together, if you add this one together, you will have this. Then you bring this 8 down. Then look again. This divided by this. What are you going to have? You have 3x. Then you multiply it again. 3 times 3, you have 3x squared. This multiplied by this, you will have here you have this This multiply by this. Here you will have C3. Here we have this. You have this multiply by this. Okay, is 2. Sorry. So what we have here is 2. Here is 2. 2. So you have this one as 2. So this multiply by this. This times this. So you will have 4x. Again, this minus this 0. Now look. Again, this the factor here is not here. So you do it like this one again. That one 0x minus 4x is going to give you 4x. So you bring this one down again. Then this divided by this, you will have 4. Then this times this, you will have 4x. This times this, you will have this. Minus 2 times 4, 8. Then you minus again. 0 minus 8 minus 8. This is it. Minus 8 minus 8. So this is plus. So 8 minus 8, 0. Now, you divided it. That's what you can now have that expression as this. This raised to power, you can have them as x minus 2 x squared plus 2x plus 4 over x minus 2. This one is tending to 2. So please cancel this. What do you have now? X tend to 2 equal to x, this one here squared, plus 2x plus 4. So substitute into this. So you will have 2 squared plus 2 times 2 plus 2. So your answer is what? You will have this one as what? 4 plus 4 plus 4. That's 12. So that is it. Now, though this method, you don't use it much for secondary school, but you can just have knowledge of it. You call it the hospital rule, or Benoni, the hospital rule or Benoni theorem. So here you have the hospital rule. What is simply, let's go back to the first one we did. X squared minus 5x plus 6 over x minus 2. Look, as the limit is as x tends to 2, we want to confirm something. Now, since the rest of the here give you 0 indeterminate, so you can use the hospital rule or Benoni theorem. What is there is that you can differentiate, that is, you differentiate this and you differentiate this. When you differentiate the two, then you can now substitute. That is Benoni or L'Hopital rule. Now look, differential calculus, that's what we are going to. But you can have knowledge of it now. Differential, what does it mean? Talking about the rate of change. That is, if y is a function of x. What differential calculus means is the rate of change. What will be the effect of the rate of change of this, of x, on y? That is, if there's a little change in this, what effect is it going to have? So you can, let's say we express this one like this, x raised to power n. The differentials mean the rate of change, we call delta. Delta, the rate of change of y with respect to x. What effect is it going to produce here? So that's what we mean by what? That's what we mean by differential calculus. So you have this one, the delta mean change. You have it in that's the meaning of you have it in economics or other physics and other subjects. So delta, when you have that, don't mean the rate of change of y with respect to x. So what this one means is x, this power here, you bring it in. So you have it like this, nx raised to power this. That's it. That is the effect. This is the effect of the rate of change of x with respect to y. The rate of change of y with respect to x. That's it. Some in simple terms, they call it the y dx. So that is it. Now, that's what we want to apply here. That is, what this one means is that if you have s raised to power 5, what will be the rate of change of y with respect to y? If y equal to this, what will be the rate of change of y with respect to x? Is going to give you 5x, then 5 minus 1, which is 5x 4. So that's it. So that's all you have here. This 5 here, 5 minus 1. So you have it like that. So that's it. So now what we are going to apply here. So you have it like this. So the s squared, this one, minus 5x plus 6 dx divided by dx minus 2 dx. So this is what you have. So for this one, x squared is going to be 2x. 2 minus 1 is going to give you 1. So you have it like this. Again, this is 5x. 1 minus 1. 1 minus 1 is 0. So anything raised by 0 is 1. So here you have 5. Derivative of constant is 0. So derivative of constant is 0. So you have this. Then what about derivative of this one? So that's what you have. So the answer now is that x, the limit, equal to this 2x minus 5 divided by 1. So you can now substitute. If you substitute, what are you going to have? 2 times 2 minus 5. So what you have is 4 minus 5, which is equal to minus 1. It's still the same thing with what we have the other time. So that's it. If it is like that, if direct solution cannot work, you can use hopital rule, which we call Bernoulli theorem, or you can use factoring method if that one doesn't apply. So we can equally test it on the second one that we did. So the second one you have here is x raised to power 3 minus 8 over x minus 2. So the limit here is x tend to 2. So what do you have? So you have the derivative of this x raised to power this x dx over dx. So derivative of this, what is it going to give you? The rate of this x raised to power 3 is going to give you 3x squared. Then if you derivative of something like this, if we call it constant, derivative of a constant is 0. I will tell you later how is 0. So that's 0. So you can have this one like this, divided by derivative of x, that's 1. X raised to power 1. If you bring the 1 here, you have times x, 1 minus 1. So that's 0. So 1 minus 1 is 0. Anything raised to power 0 is what? 1. 1 times 1 is 1. So you have it like that. So here you have the limit s tend to 2. So you can now substitute. So what do you have? 3 times 2 squared. 3 times 4. So we still get the same thing, 12. So that is the hopital rule. Then, or Bernoulli theorem. Now, look at another one. Let's say you have, they give you something like this. Here you have 1 minus cos x over sine square over sine this x. Then here is the limit as s tend to 0. Now, if you want to use direct substitution here, let's say you want to use direct substitution here, what you have here is, let's say, if you want to use direct substitution, how are you going to use it? That's what we are going. So if you put 0 here, cos 0 is 1. 1 minus 1 is 0. And sine 0 is what? Is 0. So that will be indeterminate. Then you can look at another way how you can do it. So let's say if you are let's have it like this. So what do you have here? You have 1 minus cos x over sine x. Let's say times what? Sine square x. So this is what we have here. Then as we have this one here, look at something. Here you have 1 minus. Here we have this sine x. Let's have this one like this. 1 this sine x. So if we have this one like this, so let's follow like this. So what we have here is this. In trigonometry identity, what we stated the other time is sine square x plus cos square x equal to 1. So for this one, you can find an expression for it. Sine square x equal to 1 minus cos square x. So you can come and substitute here cos x over what? Sine x. So you have sine x into 1 minus cos x. Now, what you have here, that's cos x squared. So what you have here, this cancel this. Then you have what you now have here is you have 1 minus cos x over 1 minus cos square x. Again, this is like something like this. You can express this one as 1 minus cos x over 1 square minus cos square x. That is, you have something like this, a square minus b square. So expansion of this is a minus this to what? A plus b. So if you want to expand this, you go like this. Use this method. This is how to factorize a square minus b square. So having that, so you come down here. 1 minus cos x over 1 minus cos x into brackets. Then here you will have 1 plus cos x to brackets. Now, as you are following, now look at this. What you have here, this is what you have here. Then this can cancel this. Then you bring in what you have there. The limit s tend to 0 equal to 1 over 1 plus cos x. Therefore, 1 over 1 plus. So what do you have here? Cos 0, which is 1 plus 1 plus 1, 1 over 2. So that is it. That's what you have. Now, you can equally have other method. But the method you are going to use depend on the expression, especially under trigonometry or radical value. If they give you radical equation, so you use what do you call it? Rationalization to do it. First for rationalize. So it's not really the method, but here is that when you rationalize, it will give you the value that will give it to that. Now look, let's say you have something like this. The limit of there you have here you have 1 minus cos x over sine x. Let's see, x tend to 0. If x tend to 0, sine 0 is 0. Automatically, even if this one is 1, 2 divided by 0 is infinity. So there's no solution for that. Since this one has no solution, what are you going to do? So you can use rationalization method. How? Now, in that case, let's say you have this one as squared. Then in that case, well, just you can leave it like this. In that case, what are you going to do? What you have here is 1 plus cos x over sine x. What we are going to do here, you rationalize. What I'm saying is this. What will give you the method we are going to use? In this case, the other one, what we do is we factorize it, even though it's trigonometry. But here, this is another trigonometry. Here, because it's only x, this one is only sine x. If since this one is sine x, if it is like the other one, raised to power 2 or 3, we can use factorization method also. So just substitute for trigonometry identity. But now, for this one is like this, so you can rationalize. That's like another method. You rationalize it. So when you rationalize, this one will be lifted. So you can follow. How are you going to rationalize? This value, you simply change this sign plus to minus. So you multiply it up and down. Cos x over minus cos x. This is what you have. So for this, if you say this times this, you are going to have this. This multiplied by this, you are going to have cos x. This multiplied by this, you are going to have cos x also. Then this multiplied by this, cos x multiplied by that, as you have cos square x minus sine x into bracket cos x. So I believe you are still following. What we do simply do is that, look, this sign, if you want to rationalize, you change this one, you change the sign to minus minus. It's still the same thing. This divided by this is C1. So it has no effect, it has no change. It's still the same thing. Now look, what you have here is cos x minus sine x, that's 0. So you come here, x tend to what? X tend to 0. So then you will have 1 minus cos square x over sine x into bracket 1 minus cos x. So again, you have 1 minus cos x, cos square x. This 1 minus cos square x is equal to sine square x over sine x into what? Cos x. So this can cancel this, then you have sine x over 1 minus cos x. So here is, as this one tend towards 0. Now look at what we have here. This is what we have. But if you substitute for this one, what is it going to give you? 1 is 0. That's 1. 1 minus 1 will still give you 0. So you still lead to indeterminate value. So direct substitution doesn't work. Even if you rationalize this one, it doesn't work. So what can work? Since this one cannot work, now look at it. Factoring method cannot work. So the method that remains, because if you substitute for that, it is going to give you 0, 0. That is, what we get there is 1 minus cos. This is, you have sine over what? 1 minus cos x. So this one will begin to give you 0 minus 1. 1 minus 1. That's 0 over 0. So it doesn't work. So you can use L'Hopital rule. So if you want to use L'Hopital rule, derivative of 1 plus cos x dx, derivative of sine x dx. Now look, derivative of 1 constant is 0. What's the derivative of this? Of cos x. Derivative of cos x is minus sine x over. So what is the derivative of sine x? Is cos x. Now look at it. Derivative of sine x is cos x, while derivative of what? Cos x is minus sine. So you come back here, x tend to what? 0. So what will this one work for it? Yes. So what you have here is minus 1. If you substitute this for sine 0 is 0. So anything here is 0. 0 multiplied by minus multiplied by 0 is 0. Divided by what is cos 0? Cos 0 is 1. So your answer is going to be 0. That's it. It's not indeterminate because the answer is 0. So that is the answer. What I'm saying, the question will determine the method you are going to use. Is that direct? Even if you use factoring method, it can still lead to indeterminate. So you go and use another method that will not lead to indeterminate. So it is the question that determines how you are going to approach, what the method you are going to use. If you use the method and lead to indeterminate, so you know that that's not the solution. That's what the solution is another thing. You are going to use another method. So like this one, and when you use rationalization, it not give us the answer. So it still lead to indeterminate. So you come and use the hopital rule. Since we can't factorize anything here, so that is it. Then the rest of the doesn't work. So is one is going to determine. So you can use rationalization method to do some other thing, some other one. Let's say you have something like this. Let's say you have something like this. 1 minus sine theta over 1 minus sine theta. Now, what you have here is the limit. The limit s tends to 1, to 0. S tends to 0. Now, if you have something like this, what are you going to use? So, you can use rationalizing method. So, the first thing you are going to do is that you rationalize it like this. 1 plus sine x over 1 minus sine x. So here is going to give you plus sine x over 1 plus sine x. Remember, here we are rationalizing it. We want to rationalize. So, like rationalizing method. So, what you have here is this one will simply give you 1 plus sine x squared. Why this one is going to give you 1 minus this multiplied by this, you have this time this you will have sine x. This multiplied by this, you will have minus sine x, then minus sine square x. Minus sine square x. So, into brackets. Then you come here. You have 1 plus sine square x over this minus this. What you have is 1 minus sine square x. So, you put your limit here, s tends to 0. So, since this is squared, you have this one as 1 plus sine x. This 1 plus sine x, this is squared. There you have square root over. Now, from the trigonometry identity the other time, you know this one, sine square x plus cos square x equal to 1. So if you make cos the subject of the formula, you have 1 minus sine square x. So this one you replace this one with this. So your answer is going to be this. Your answer is going to be this. 1 plus sine square x. 1 minus square x over cos square x. Now, then from here, you transfer it here. You can reexpress this one like this. Look, in sod, if you have a squared over b squared, you can simply express as a over b into bracket squared. So it's still the same thing. So that's what we are going to do here. This one is squared. Why this one is squared? So you have 1 plus sine x over cos x squared, all into square. X tend towards 0. That's the limit. Then this one will cancel this. Then you will have this x tend to 0 equal to 1 plus sine x over cos x. Now, this the solution now. We want to test it now. Can this one work? Remember the one we did the other time did not work. Then we use the hopital rule. What about this one? Does the rationalization solve this one? So 0. So you have substitute directly now. You have 1 plus sine 0. Here you have sine 0 over cos 0. So sine 0 is 0 over cos 0, 1. So 1 divided by 1 is 1. So the limit is 1. That is it. Now remain another one. I want to show you like that. Before you go to that, I want you to know something. Any number divided by infinity is 0. If you have x divided by infinity, it's going to give you 0. So you note that. And if you have any number divided by 0, it's going to give you infinity. So you note this one first. Now, there are some expression that is not factorizable. And it's not factorizable. And all what you can do. And again, one, it's not, even though it's not factorizable. And again, the limit is 10 to infinity. Once the limit is 10 to infinity, so what we are going to do is the method of dividing by the highest degree from each numerator and denominator. What I'm saying is this. Let's say you have x raised to power 3 minus 5x squared plus 6x minus 3 over x raised to power 3 plus 2x squared minus x plus 2. Now, the limit now says that x tends to infinity. Now, here, you can't use direct. When you can substitute for direct, it's going to give you indeterminate. Here, this one is power, infinity is infinity. Minus, plus, infinity, and all together divided by infinity is going to give you infinity, indeterminate. So how are you going to solve it? So that's it. The method of what? Method of dividing each numerator and denominator by the highest degree or power. By highest degree or power. That is it. What I told you, when you are doing limits, the method you are going to use is determined by the question that you are given. It's not static that you can solve this one like this. You first of all read the question, and how it is what is going to show you how you are going to solve it. So let's follow. Since this one is like this, so what you are going to do is you take the highest value. So you divide each by it. Here you have this raised to power 3 divided by x raised to power 3 minus 5x raised to power 2 divided by x raised to power 3. The highest degree you pick here is x raised to power 3. then plus 6x divided by x raised to power 3 minus 3x raised to power 3 divided by this. So here you have s again raised to power divided by 3 plus 2x squared divided x raised to power 3 minus s raised to power 3 plus 2s raised to power 3. So both up and down, the limit as x tend to infinity. So this will cancel this. What do you have? 1. Then this 3. This cancel this. You have minus 5 over x. What about this one? You have 6. That's 6 squared. Because once only cancel this. This one remains 2. So you have this one 3 over x raised to power 3 divided by, look, this cancel this 1 plus this go for this 2x. This go for this 1 over x squared plus 2x to power 3. So the limit as s tend to infinity. Now look, here you have 1 minus 5. Now substitute for infinity now. Plus 6 infinity squared minus 3 divided by infinity raised to power 3 over 1 plus 2 over infinity minus 1 over what? Infinity squared plus 2 over infinity raised to power 3. Now, come back to what I told you. I said number divided by infinity. Infinity is infinity. Infinity raised to power 100 is still infinity. So, all this one you are seeing, they are all infinity. E raised to power 3, 4, 5, 6, 99, 100, 1000. So, you have it in mind like that. So, what you have now is this is 1 minus 5 divided by infinity is 0 plus 6 divided by infinity is 0. 3 divided by infinity is 0 divided by what? 1 plus 2 divided by infinity is 0 minus 0 plus 0. So all this divided by this, 1 divided by 1. So your answer is 1. So that is that about limits. So that is that about limits. If you want to, well, you have it like that. So you get your textbook and then do some questions there. Solve some questions there. Like, let me give you something to solve. Let's say you have the solve this. Here you have x2. Here you have x squared plus 10x plus 25. As this one tend to what? Tend to 0. That's question 1. Question 2. Look at this. 4x squared minus 4x squared minus 4. 4x squared minus 4. That's 2x minus 2. Let's say you have x squared minus 25, x minus 5. So have this one like this. You have this one like this. So the limit x 10 to 5. So you have something like this. Then look, 3. Let's say you have this. Here you have 3x squared plus 2x minus 5 over 4x squared minus 3x plus 2. So solve this, what I would like you to do is get your textbook and practice. There are a lot of questions there in your textbook, project or other one. Just get it and make sure that you practice. If you want to be expert in mathematics, you have to practice it. You have the time. Instead of you to be pressing your phone, do some other thing. Just get your book and practice. That's the pathway to excellence. So thanks for watching. I want you to tell your friend, introduce your friends to this channel so they can get themselves equipped and then subscribe, help us to subscribe to the channel. So anytime that we release any we post anything there, so you'll be alerted. Thanks for watching.